Hi everyone, welcome to Go Classes. So in the last session, in the last lecture, we were discussing this pumping lemma. We will continue the discussion. This is lecture 2, or I can say pumping lemma part 2. So far, in part 1, what we have seen? In part 1, we have seen what is pumping lemma. This is what we have seen in the part 1. Okay. And now in this session, we will take more examples, more questions we will take for practice and to understand the pumping lemma in a better way. Okay. So now let's start. So this is our part 2 of pumping lemma. In part 1, we have already seen what is pumping lemma. 3 examples also we have taken. Now let's continue. Let's take some more examples. But before that, let me tell you what is pumping lemma. What is pumping lemma? So this we have already seen, right? What is pumping lemma? This we have already seen. So let me just revise. Let me quickly revise. What is pumping lemma? Pumping lemma says that what this pumping lemma says. This pumping lemma, or I can say this pumping lemma theorem. This is a theorem, pumping theorem you can say. Okay. So what this theorem says, this theorem says that if L is regular, okay, if language L is a regular language, then something will happen. If L is regular, then what will happen? Then I can say if L is regular, then something will happen. This is what this pumping lemma says. Okay. So this pumping lemma, this theorem, this is a theorem, and this theorem says that if L is regular, then definitely this something will happen. Now, what is this something? So let's see. Now, this pumping lemma says that if this L is regular, then this L has a magical number. Yes or no? If L is regular, then what will happen? Then I can say that L has a magical number. It has a magical number. Okay, it has a magical number P. Remember this point, remember this P, remember this is a positive integer. Yes or no? This P is greater than equal to 1, and this P is a positive integer. This P, this is a positive integer. This is an integer. Okay, so this is a positive integer. Now, the statement is saying that L has a magical number such that every candidate string pumps. Yes or no? Such that every candidate string pumps. Every candidate string pumps. Yes or no? In simple words, can I say like this? Tell me, in simple words, very small statement. See, this pumping lemma statement, we have converted this to a very small statement. So this pumping lemma says that if L is regular, then L has a magical number P such that every candidate string pumps. Now, can anyone tell me what is this candidate string? Can anyone tell me what are the candidate strings? Remember, candidate strings are those strings. Remember, these are the candidate strings which belong to L and whose length is greater than equal to P. These strings are candidate strings, and these strings will pump. Okay, every such string will pump. Is this clear? Every such string will pump. So this is a very simple point. So remember this point, that pumping lemma says if L is regular, then L has a magical number P. This L, this language L, this has a magical number P such that every candidate string pumps. And what is a candidate string? This candidate string, this means W belongs to L and length of W is greater than equal to P. Okay. And tell me, what is the name of this magical number? This magical number P, this is called pumping length. This magical number P, this is called pumping length. This is called pumping length. Now you tell me what this means. This pumps, what this means. Candidate string pumps. Now what this means? This is what we need to find out. So this simply means that, remember, I can say such that for every W which belongs to L and whose length is greater than equal to P, for every such W, these are your candidate strings. Okay. So for every such W, what is going to happen? For every such W, I can say for every such W, okay, such that I can say for every such W, what will happen? In the initial P symbols, okay, yes or no? I can say in the initial P symbols of W, there is some non-empty Y, there is some non-empty section Y, which can be repeated any number of times such that the resulting string belongs to language L. So this is the point, that for every such string, these are your candidate strings. Remember, these are the candidate strings. I can simply say that for every such string, what will happen? That I can say in the initial p symbols, within the initial p symbols, or I can say within the initial p symbols, what will happen? Within the initial p symbols of W, I can say there is at least one, okay, there is at least one non-empty section Y. There is at least one non-empty substring Y. Okay, there is at least one non-empty substring Y, such that I can say such that this Y can be repeated any number of times. Y can be repeated any number of times. Y can be repeated, I can say greater than or equal to 0 times. Any number of times you can repeat, and resulting string belongs to L. And resulting string and result is in L. Okay, so this is the statement. I hope this point is clear. So very simple, this is your pumping lemma statement. In this pumping lemma statement, I can say that for any language, this is what you need to do. Okay, what we need to do. So you have a language L. For this language L, what we need to do? If you assume, if you take this magical number P, if you take this magical number equal to P, then what you need to do? If you take this magical number equal to P, then in this L, which strings you need to consider? This is your language L. In this language L, you only need to consider these strings. These strings you need to consider whose length is greater than equal to P from L. Okay, from L. Remember, this W belongs to L. So I can say for these strings, what will happen? If you take any of these strings, for every such W, what will happen? This is your W. This is your W. Then remember, within the first P symbols, these are the first P symbols. Let's assume these are the initial P symbols. These are the initial P symbols. Now within the first P symbols, there exists a non-empty section Y. Okay, there exists a non-empty section Y. If this is your non-empty section Y, then you tell me the left of it. Okay, on left there is something, on left there is something, on right there is something. What we call it? On left, what we call? Left of Y, let's call it X. And left and right of Y, that is your Z. Okay, now tell me what will happen then? Okay, then what will happen now? Then this will happen that this Y you can repeat any number of times. Okay, this Y you can repeat any number of times. You can repeat it any number of times such that the result will belong to L. Okay, you can repeat this Y any number of times. So this is the point. Okay, this diagram you can understand. Okay, this diagram you remember. For every W, this will happen. For every candidate string W, this will happen. So this diagram you understand. That's it. Only you remember this diagram. Okay, and this is your some non-empty section. Remember, this is at least one non-empty section. This is some non-empty section, or I can say substring. This is your some non-empty section. That's it. Okay, this X comma Y, this X comma Z, they can be anything, right? Yes or no? This X comma Z, they can be anything. They can be empty, they can be anything. Okay, so we don't care about X comma Z. The only thing that matters, this Y matters. Okay, on left of Y, everything is X. On right of Y, everything is Z. Okay, they can be empty also. Okay, now if you repeat this Y any number of times, the resulting string should belong to L. This type of Y we look for. Okay, we want this type of Y. So that's it. This is your pumping lemma statement. So now let's see this question. Let's start with this question. Read this question. First of all, the question is saying, if P is a pumping length for a regular language L, then P plus 1 is also a pumping length. This is a standard question from a standard university, from a top university. This question is taken. So read this first line and tell me, did we see this first line in the last lecture? In the last lecture, did we see this? We have already seen this. Yes or no? If P is a pumping length for regular language L, then P plus 1 is also a pumping length. This we have already seen. So this first line is just what we have seen in the last lecture. You already know this first line, what it means. You already know. Okay, we already know this point, that for any language L, for any language So this is the first line, that for any language L, if P works, okay, if P works, I can say if P works, if P is the pumping length, then every n greater than equal to P. Remember, then every n greater than equal to P also works. Okay, so very simple. If P is pumping length, then I can say every number greater than equal to P is also pumping length. Okay, very simple point, that if P is pumping length, if this is the magical number, if this is pumping length for L, if this is the magical number for L, then every number greater than equal to P, then every number greater than equal to P is also a magical number for P, is also pumping length for L. Very simple. So this is the point. This we already know. Now let's see the next. So tell me, now the question is saying, if this, from this property, can you notice there must be a minimum pumping length? Yes or no? See, from this property you can notice from this property you can notice there is a minimum pumping length. You can find minimum pumping length for any regular language. Okay, so now the question is saying, for example, the minimum pumping length for this language is 3. Let's prove it. Okay, let's take it as a question. So you tell me. Let's take it as a question. I give you this language where alphabet is ABC. So this is your alphabet. I give you this language C, AB, whole star. Find the minimum pumping length. This is the question. Okay, what you need? First of all, you tell me, is this the regular language? Is this regular language? Yes, this is a regular language. You already know. Why this is a regular language? Can anyone tell me? What is the proof? Why this is a regular language? Because this itself is a regular expression, or you can create DFA, you can create NFA. This itself is a regular expression. Okay, this itself is regular expression. Or you can create DFA. You can easily create DFA for this. Okay, so that you can take as homework, creating DFA. So for this language, create DFA, that you can take as homework. Create DFA, create NFA, these things you create. Okay, so first you create DFA, then you create NFA. This is your homework. You can take this as a homework. Okay, you can try this. Anyway, now you tell me here. So this is your alphabet and this is your language. Now for this language, what we want, this is a regular language. First of all, you find the minimum pumping length. You find the minimum pumping length. So find minimum pumping length. Also prove that this will satisfy pumping lemma. Okay, if we can find minimum pumping length, tell me, if we can find this, then can I say that L satisfies pumping lemma? Yes, of course. If I can find pumping length, if I can find this, okay, then definitely L will satisfy pumping lemma. Okay, now let's find out. So tell me, first of all, this is your language. First you understand the language. In this language, what are the strings? This type of strings you have C, CAB, CAB, AB, CAB, AB, okay, and so on, and so on. So this type of strings you have. Now you tell me, first of all, tell me P equal to 1, will it work? Okay, just check one by one. Okay, let's start. P equal to 1, does it work? Does it work? P equal to 1 works. Does it work or not? Okay, tell me why this does not work. If I take P equal to 1, then what are the candidate strings? You just tell me what are the candidate strings. First, you find what are the candidate strings. What are the candidate strings? Okay, then your candidate strings are, I can say, every string in L. Yes or no? Every string in L is candidate string. Okay, your candidate string are every string of L. Every string of L is candidate string. Every string of L. These are your candidate strings. Yes or no? Correct. Okay, so very simple. Because your candidate strings, they must belong to L. Also, their length must be greater than equal to 1. So these are your candidate strings. These are the candidate strings. Now tell me, which candidate string will definitely violate? See, notice one thing. Notice one thing. If I take this candidate string, will it violate? If I take this candidate string, will it violate? Does it violate? Does this candidate string violate? Look at this candidate string and tell me, does it violate? Why it violates? Why will it violate? Does this candidate string violate pumping lemma? So first of all, you tell me one thing. Can I take this as a y? Can I take this as y? Just tell me one question I'm asking. In this CAB, this is your string CAB. Can I take this as y? I cannot take this as y. Okay, this will be wrong. I cannot take this as y. Okay, this is going to be wrong. Why this is wrong? Because if your p is equal to 1, then y must be in the first one symbol. Y must be present in first p symbols. Okay, yes or no? Y must be present within the initial p symbols. So you cannot take this as y because we are checking p equal to 1. So tell me now, for p equal to 1, your y will be what? There is only one possibility for y. This will be your y. Okay, now if you repeat it 0 times, if you repeat this y 0 times, first of all, one more thing. What is x? X is equal to empty string. X means whatever is on left of y. X means left of y. Left of y is empty string. What is z? Z is AB. Now you tell me, if I repeat this y 0 times, the result will belong to L or not? If I repeat this y 0 times, this is your string. Your string is CAB, and this is your y, and your x is empty string, and your z is AB. Now you tell me, if I repeat this x y power 0 z, what is this? What will be this? This is your empty string. Y power 0, that is always empty string. Y power 0, that is always empty string, and this is AB. So finally you will get it. You will get AB. Does it belong to L? No, it does not belong to L. Okay, does it belong to L? No. So can I say this string violates? So I can say that this string, I can say this string violates. This string violates pumping lemma. Okay, this string violates pumping lemma when you consider p equal to 1. Okay, yes or no? When we consider p equal to 1, is this clear? This string violates pumping lemma when you consider p equal to 1. Okay, very simple. So I can say p equal to 1 will not work. P equal to 1, this will not work. So this is the conclusion, that p equal to 1 will not work. I can say, does it work? The answer is no. Okay, the answer is no. So I can say, so definitely p equal to 1 is not pumping length for L. Is not pumping length for L. For this language, this p equal to 1 is not a pumping length. Okay. Now you tell me, what about p equal to 2? What about p equal to 2? Will it work? First of all, you tell me what are the candidate strings. If you take p equal to 2, then what will be your candidate strings? You just tell me the candidate strings. If you consider p equal to 2, then your candidate strings will be these. These will be your candidate strings. I can say, for example, CAB, AB, and so on. These are the candidate strings. Now you tell me, which string will violate if I take p equal to 2? Which string will violate if I take p equal to 2? Again, you can notice that every string will violate. Again, you can notice every string will violate. So again, you can easily notice, if you take this string CAB, then this will also violate. This will also violate. Will it pump? Or I can say, see, I can say that this violates, or I can say that this will not pump. Okay, this string does not pump. This string does not pump. Yes or no? This string does not pump. Why this string does not pump? Let's check. So first of all, you tell me where you will find y. This is your string, but in this string, where you will look for y. This is your string. So your y will be within first two symbols. Y must be here. In this area, y must be there. In this area you find y. Okay. In this area you find y. Tell me how many possibilities are there for y. In this area you find y. How many possibilities are there for y? There are 3 possibilities for y. Yes or no? There are 3 possibilities for y. Remember, this is your string CAB. In this string, you can notice this is your entire string, but in this entire string, your y must be here. In this area, you must find y. Now, for this y, there are 3 possibilities. There are 3 possibilities only. What are those 3 possibilities? Three possibilities. What are those? You can take y equal to c, you can take y equal to a, or you can take y equal to ca. Yes or no? These are the three possibilities for y. Tell me, any of them, will they work? Will any of them work? Will any of them work? If you repeat any of them 0 times, then result will not belong to L. You can easily notice. See, if you repeat 0 times, if you repeat 0 times, if you repeat any of them 0 times, then the result will not belong to L. Again, this also, if you repeat 0 times, if you repeat this also 0 times, then this will also not belong to L. And if you again repeat this also, if you repeat 0 times, this also you repeat 0 times, then the result will not belong to L. So did you notice there is no such y? Yes or no? Did you notice? See, if you take this equal to y and you repeat 0 times, what you will get? I take this as y. I repeat it 0 times. I will get AB. AB does not belong to L. Yes or no? If I repeat this 0 times, I will get AB, and AB does not belong to L. AB does not belong to L. Similarly, if I take this equal to y, this equal to y, and I repeat this 0 times, what I will get? I repeat this 0 times, this string A, I repeat it 0 times, then I will get CB. CB also does not belong to L. And if I take this equal to y, if I take this equal to y, I repeat it 0 times, what I will get? This equal to y. I repeat it 0 times, I will get B, and that also does not belong to L. So can I say no y works? I can say no y possible. No y possible. Okay, but pumping lemma says there must be at least one y. Yes or no? See, no y is possible, but pumping lemma says there must be at least one y. Pumping lemma says, okay, you must have some y. Pumping lemma says we must have some y. At least one y must have. So can I say that this string will violate? This string will violate pumping lemma if you consider p equal to 2. Okay, so again you can easily notice. So if we consider, so remember, if we consider p equal to 2, then these strings are the violating strings. This CAB, AB, and all these strings will violate. All these candidate strings will violate. All these candidate strings will violate. Candidate strings, all these candidate strings will not pump, or I can say will violate. Okay, will violate pumping lemma. Violate pumping lemma, and I can simply say they will not pump. Okay, they will not pump. I can simply say they will not pump. Okay, these strings will not pump. So simple, very simple. So this p equal to 2 also does not work. Yes or no? The question was, does it work? And the answer is, this does not work. No, this p equal to 2 does not work. So I can say p equal to 2. So p equal to 2 is not a pumping length for L. Yes or no? It is not a pumping length for L. It is not a pumping length for L. Very simple. Now, finally, p equal to 3. Let's check. P equal to 3. So remember, let's check p equal to 3. Does it work? If you take p equal to 3, what are your candidate strings? You tell me that. First of all, you find out what are the candidate strings. What are the candidate strings? If you take p equal to 3, these are the candidate strings whose length is greater than equal to 3 and who are in the language. Okay, so these are the candidate strings. Now you tell me, if I take p equal to 3 and I take, remember, only these strings I care about. I care about these strings. These are the candidate strings. Okay, so tell me, will they pump? For example, is this CAB pumping? Like if I take this CAB, this is your CAB. First of all, you tell me in which area you will find y. First of all, you tell me, if you are checking p equal to 3, then in this area you will find y. In the first 3 symbols, in this area you will find y. You will find y. Okay, tell me one more thing. Will it work if I take y equal to this? Will it work? If I take y equal to this, will it work? It will not work. So can I say this string will not pump? Can I say this string is saying I will not pump? Can I say? See, this y will not work. If you take y equal to a, then this string will not pump. So can I say this string will not pump? No, find some other y. Yes or no? This y is not working, so find some other y. The point is, there must be at least one y such that this string will pump. There must be at least one y. You just find at least one y such that this string will pump. So tell me which y I can take. I can take this y. I can take this y. Okay, take this y. Now, if you take this y, you tell me what will be your x. Then what will be your x? X will be left of y. X will be left of y. What is z? Z is right of y. That is empty string. So you tell me, can I say x, y power n, whatever power you do, z, can I say it will belong to L? Whatever power I put. If I put 0 power, what will be the resulting string? Tell me. For example, if I put this 0 power, then the resulting string will be C, and you can notice C belongs to L. C belongs to L. See, if I take this power 0, if I repeat this 0 times, then this will be gone. Now the resulting string belongs to L. The resulting string is belonging to L. If I repeat it 2 times, then also the resulting string will belong to L. I can repeat it any number of times, the resulting string will belong to L. So can I say that if you take p equal to 3, every candidate string is pumping? P equal to 3. If I take p equal to 3, see, you can take any candidate string, C, A, B, A, B. In which area I will find y? This is your p equal to 3. I am checking p equal to 3. So in which area I will check? Yes, in this area you must find y. So remember, this is your string. This is your string, but your y must be within the first 3 symbols. In this area you find y. Okay, now you can easily notice that this y will work. If you take this y, that will work. In this situation, your x is C and your z is right of y, that is AB. Now you can again easily notice that x, you can repeat this y any number of times. Okay, that result will belong to L. Result will belong to L. You can repeat any number of times, the result will belong to L. Very simple. So I can simply say that every candidate string will pump. So very simple. For this language, remember, I can say, if we take p equal to 3, or I can say for p equal to 3, every candidate string pumps. Every candidate string pumps. And this is what we want. Yes or no? Agree? So for this magical number, every candidate string pumps. For this magical number, every candidate string is pumping. So I can say this language will satisfy pumping lemma. So L satisfies pumping lemma. L satisfies pumping lemma. Okay, L passes pumping lemma, or I can say L has passed pumping lemma. This pumping lemma test. L has passed pumping lemma test. Okay, L did not fail. L is not failing. L passed pumping lemma test. L has satisfied pumping lemma. And what is the minimum pumping length? What is the minimum pumping length which is working? Minimum pumping length 3 is working. So can I say 4 is a pumping length? Yes, 4 is also a pumping length. So for this language, I can say for this language, what are the pumping lengths? What are the pumping lengths? Pumping lengths, any number greater than equal to 3. Pumping lengths are any number greater than equal to 3. Okay, any number greater than equal to 3. Is this point clear? Let me tell you one thing. Let me tell you. See, in this GATE 2019. Yes, I think GATE 2019. Okay, in this GATE 2019, let me tell you. In this GATE 2019, there is a question. There is a question on pumping lemma. Okay, in that question, this language L is given to you. This regular language is given to you. Okay, a regular language is given to you. And for this regular language, they are asking pumping length. See, they are not asking minimum pumping length. Okay, the question is asking pumping length. The question is asking pumping length. Is this point clear? The question is asking pumping length. The question is not asking minimum pumping length. Is this clear? The question is not asking minimum pumping length. Not asking minimum pumping length. Now notice something interesting. This question many students could not do. Let me tell you. And this was MCQ question. So what was beautiful in this question? See, just think about it. If I give you some regular language, okay, just think about it. I will not even give you the language. Okay, I will not tell you the language, but you can solve this GATE 2019 question easily. See, in this GATE 2019 question, a regular language is given to you. A regular language L is given to you, and the question is asking pumping length. The question is asking which pumping length will work. What is the pumping length? And some options are given to you. Options are like this: 5. Option B. Option B is, let's assume, that is 9. Option C is, let's assume, 11 or 12 or maybe 11. Okay, and option D was 24. So tell me, what will be the answer? Without looking at the language, can you say what will be the answer? This was MCQ question, not MSQ. This was MCQ question. Means only one option you can tick. Only one option you can tick. So tell me, without checking the language, can you say answer will definitely be 24? Why? Tell me. Without checking the language, why answer is 24? Because if answer is 11, then 24 will also be the answer. Yes or no? Just think like this. Think like this. If this is the answer, then all the options will be correct. If this is the answer, then these two options will be correct. But the point is, if one of them is correct, then definitely this 24 will be correct. Do you agree with me? See, if this is the answer, then every number is a pumping length. If 5 is a pumping length, then every number is a pumping length. If this 9 is a pumping length, then every number greater than equal to 9 is a pumping length. The point is, if one of them is the answer, if one of them is a pumping length, then definitely this will be the pumping length. If this is a pumping length, if 11 is the pumping length, then 24 will also be the pumping length. But the point is, 24 will be the answer. And let me tell you, for this question, actually, if you find minimum pumping length, we will solve this question. Don't worry. Okay. Don't worry. We will solve this question. You can find my answer on GATEOverflow website. For this question, you can find my detailed answer. In that detailed answer, I have found minimum pumping length also. Okay. Don't worry. We will solve it in the class. In the lectures, we will solve. Don't worry. Okay. But the point is, you can find my explanation. My detailed explanation you can find on GATEOverflow. On GATEOverflow website, you can find my detailed explanation for this question. I have found this minimum pumping length, and I think this was this minimum pumping length. I think this was 13 or 14, something like that. Can you check? Someone can someone check? I have found in my answer. You can check minimum pumping length. I think that is 13 or 14 or something, or maybe 12. Okay, minimum pumping length, I think that is 12. You can check it out. In my explanation, you can check it out. Don't worry about this question. Do not worry about this question. This question we will solve in lecture. In class, we will solve this question. But you can see this minimum pumping length, you can see. In my answer, you can see. Okay, anyway. So did you see that this question was very easy? Did you notice? Did you notice this question was very easy? You don't even have to solve this question. In 2019, this question came, and let me tell you, this simple question many students could not do. This simple question, I can say majority of students could not do. Even some toppers could not do. But actually, this question was so simple that you don't even have to check the language. You don't have to solve the question. Without solving the question, you can say answer will be 24. Okay. Anyway, let's move on now. Don't worry. This question we are going to solve in future. Okay. Now let's see. So finally, for this question, for this language, we have found the minimum pumping length, that is 3. Okay, let's move on now. So what this question is saying, this was our original question. They have taken this as example. See, example, the minimum pumping length for language whose regular expression is this is 3. Okay, so you can check it out. Now the question is saying that in the following problem, we have to find, for this language, we have to find the minimum pumping length. Just by looking at the language, can you tell me what will be the answer? We have to find minimum pumping length. Just by looking at the language, can you tell me what will be the answer? Just by looking at the language, without solving the question, you can say that answer will be 1. Yes or no? See, now this is your language. Your language is a power n. N is greater than equal to 0. This is your language. Okay. And for this language, you can easily notice that. For this language, you can easily notice that this p equal to 1 will work. First of all, what is this language? This has empty string, this has A, this has double A, this has triple A. Okay, this is the language. Now you can easily notice p equal to 1 will work. Okay, this will work. Why this will work? Tell me. Tell me why this will work. First of all, if you take p equal to 1, what are the candidate strings? Which strings you care about? which strings have the power to violate or satisfy? Which strings have the power to violate or satisfy? So which are the strings which you care about? Candidate strings. So these candidate strings, these are, I can say, any string which is in the language and whose length is greater than equal to 1. So I can say these are the candidate strings. Okay, now you tell me, can I say every candidate string will satisfy, will pump? For example, tell me this, will it pump? If you take this, then will it pump? So you are checking p equal to 1. So this y you can take, your x will be empty string, your z will be empty string. Now a simple question I am asking, if you repeat this y any number of times, for example 0 number of times, what string you will get? See, your x is empty string. Any string power 0, that is empty string. And this is also empty string. Finally, you will get empty string, and that belongs to the language. Empty string belongs to the language. Yes or no? Now tell me, if I repeat this y any number of times, can I definitely say that it will belong to the language? I repeat this y any number of times, the result will definitely belong to the language. Okay, so very easily you can see this will be your answer. Okay, for every n, whatever, I can repeat this any number of times, I can repeat this, and the resulting string will belong to L. So very simple. So this p equal to 1 will work. Okay, yes or no? So this p equal to 1, you can take whatever string you want. For this string, which y will work? For this string, which y will work? Can I say this y will work? Please tell me, can I say this y will work? Can I say this y will work? No. You are checking p equal to 1. So your y must be within the first one symbol. Your y must be within the first one symbol. Here you have to find the y. Okay, here you have to find the y. So very easily you can see that here finally your answer will be, what your answer? You can repeat it any number of times. Okay, here you can notice this x is empty string, this z is a, so you can repeat this any number of times. You can repeat, the result will belong to L. Okay, you can repeat any number of times. So very simple. So quite this is simple, right? Okay, now let's move on. Now before we move on, I just want to give you one question, another simple question I want to give you. Consider this language where you have a power 3, a power 5, a power 7, and so on. Okay, did you see the pattern? A power 9. So this AP, this is your language. Find the minimum pumping length. First of all, you tell me, is this regular language? Is this regular language? First of all, you tell me, is this regular language or not? Is this regular? Yes, you can create the regular expression. You can create the regular expression. The regular expression you can create like this, a power 3 and then double a any number of times. Okay, this will be your regular expression. Let's assume alphabet is only single a. This is your alphabet. Okay, so tell me, this will be your regular expression, a power 3 and any number of times this 2a can repeat. Okay, these can repeat any number of times. So this is your regular expression. Or you can say your regular expression is basically triple a, then double a whole star. This is the regular expression. So yes, this is a regular language. Okay, yes, this is a regular language. Can you create DFA for this? Can I give that as a homework? This DFA, NFA, can you take as homework? Okay, so take as homework. Now you tell me, what will be the minimum pumping length for this language? Just find the minimum pumping length. Find minimum pumping length. So tell me, what will be the minimum pumping length? First of all, you tell me, will you start from 1? Will you start from 1? No, you can directly start from, can you notice 3 will also never work. See, this is the minimum length string, right? In this language, this is the minimum length string. This is the minimum length string in L. Okay, this is the minimum length string in L. You tell me one thing. You tell me one thing. If I take p equal to 3 also, then when I repeat this y 0 times, then resulting string will have length less than 3. Yes or no? Agree or not? See what I'm saying. Very simple point I'm saying. Understand this point. In this language, this string has minimum length. Now, if you take p equal to 3, if we consider p equal to 3, then what will happen? See, if you consider p equal to 3, and this is a candidate string, now whatever y you take, if you repeat that 0 times, then the resulting string, what will be the length of that? See, are you getting my point? In this, whatever y you take, whatever y we take, if we repeat 0 times, if we repeat it 0 times, then what will happen? Then resulting string length will be what? Just tell me this point. Then resulting string length, then length of the resulting string, that will be less than or equal to 2, or I can say less than 3. That will be less than 3. Yes or no? See, whatever y I take, for example, if I take this y, then resulting string length, if I repeat 0 times, see, if I take this y and I repeat 0 times, then resulting string length will be 2. If I take this y and I repeat 0 times, then resulting string length will be 1. If I take this y and I repeat 0 times, then resulting string length will be 0. So can you notice? I can say resulting string length will be less than 3. Yes or no? Whatever y I take. For example, if I take this y and I repeat 0 times, what will be the length of the resulting string? Tell me. If I take this y and I repeat 0 times, what will be the length of resulting string? That will be 1. So I can say resulting string length will be less than 3. Yes or no? If string has length less than 3, can it belong to L? If string has length less than 3, can it belong to L? No, because in this language, the minimum length string is 3. Okay, so definitely this 3 does not work. Is this p equal to 3 does not work? Okay, I can say that this p equal to 3, this resulting string will not belong to L. This resulting string does not belong to L. Okay, so I can definitely say that if your language has minimum length n, then p equal to n will never work. Do you agree with me? If your language has minimum length string equal to n, then p equal to n will never work. So can I write this as a note? Did you understand? Tell me, did you understand? So if you have a language L, if your language L, there is some language L, in this language, if minimum length string in this language, if minimum length string has length n, then p equal to n will never work. Do you agree with me? Then p equal to n will never work. Did you understand the intuition? Did you understand the intuition? What is the intuition? Tell me. What is the intuition? Because your minimum length string has length n. Okay, and if you take p equal to n, then you repeat 0 times, then resulting string length will be less than equal to n. Yes or no? Do you agree? See what I'm saying. I'm saying this is your L. In this L, you have some strings like W1, W2, and so on. These are the strings. Let's assume this string has minimum length. Let's assume this has minimum length. This is the minimum length string in L. And let's assume its length is n. Let's assume its length is n. Now see what will happen. Now this is your W1. Your W1 is A1, A2, AN. This is your W1. Now whatever y you take and you repeat it 0 times, what will happen? Tell me. In this W1, if I take p equal to n, consider this p equal to n, then in this area you find y. In this area you find y. But the point, what is the point? The point is whatever y I take, if I repeat 0 times, if repeated 0 times, then tell me the length of the resulting string. Tell me, if I repeat 0 times, then What is the length of the resulting string? Tell me. Then the length of resulting string. What is the length of the resulting string? The length of the resulting string will definitely be less than n. Yes or no? See, y is non-empty. Y is always non-empty. Y is always non-empty. Y is always non-empty. If I repeat it 0 times, if I repeat this y 0 times, then resulting string length will be definitely less than n. That will be less than n. So from here, what I can say? Tell me. So resulting string does not belong to L. Yes or no? So resulting string does not belong to L. Why? Tell me why. Because the minimum length string has length n. Because in L, minimum length string has length n. Has length n. But the length of this, but the length of this resulting string, is less than n. So that is the reason. So can I say, so p equal to n never works? Not work. Did you understand this intuition? Very quite intuitive, right? Just think in your mind. Just think about it. Just visualize. If you repeat this y 0 times, this y itself is non-empty. Yes or no? This itself is non-empty. If you repeat it 0 times, then the resulting string length will be less than n. So this resulting string cannot belong to this language L, because in this language L, the minimum length string has the length n. Okay. Now tell me one thing. If p equal to n is not working, can p equal to n minus 1 work? Tell me one more thing. For this language L, if p equal to n does not work, can n minus 1 work? Can p less than n work? Or I can say, can p equal to n minus 1 work? The answer will be no. Why no? Tell me. If p equal to n is not working, this p equal to n is not working, then why p equal to n minus 1 will not work? By contradiction. If p equal to n minus 1 will work, then p equal to n will also work. By contradiction, I can say, if p equal to n minus 1 work, then p equal to n should also work. Correct or not? So that is the reason I can say, if p equal to n is working, then p equal to less than n, that will never work. Did you understand this? See, all the small points I am telling you. You tell me one thing. These points, all the points that I'm telling you, are you finding them difficult, or are you finding them intuitive? Like, are you understanding the explanation intuitively? Can you visualize what is happening? Can you visualize? See, this is your proof by contradiction. If p equal to n is not working, if this is not working, then p equal to n minus 1 cannot work. Because if this will work, then this also will work. Okay, so very simple. So just visualize the concept. These are simple concepts. Okay, now let's move on. Now let's take our question. Okay, so in this question, tell me directly from where you will start. You don't have to check p equal to 3, because this is the minimum length string. This is the minimum length string, and the length is 3. This is the minimum length string in L. And the length is 3. So I can say, definitely I can say p less than equal to 3 does not work. Or I can say p equal to 3 does not work. So don't even have to check. Can never work. Cannot work. So start checking from 4. Yes or no? So start checking from 4. So start with p equal to 4. Yes or no? Do you agree with me? So you start with p equal to 4. Now let's start with p equal to 4. Okay, if I take p equal to 4, what are the candidate strings? I am checking p equal to 4. You tell me my candidate strings. My candidate strings. These are the candidate strings whose length is greater than equal to 4. So my candidate strings, these are the candidate strings whose length is greater than equal to 4. So I can say a power 5, a power 7, a power 9. These are the candidate strings. Okay, yes or no? These strings which are in the language and whose length is greater than equal to 4, these strings are the candidate strings. Now you tell me, will they pump? For example, this string you take, this candidate strings I am taking candidate string. This candidate string I am taking. Okay, you tell me, will it pump? Will it pump? First of all, you tell me where you will check y. In which area you will check y? You will find y in which area? You are checking p equal to 4. So in the first 4 symbols, in this area, this is your within first 4 here in this area. These are the first 4 symbols. These are the first 4 symbols. In this area, you find y. Okay, so tell me which y will work. Can anyone tell me which y will work? Which y will work? In this area, you find y. Some students are saying double a, y equal to double a will work. Okay, let me check. For example, let me check this y equal to double a. Will it work? If I take this y, will it work? Y equal to double a, will it work? Will it work? Y equal to double a. Yes, it will work. Yes, it will work. See, if I take this y equal to double a, does it work? Does it work? If I take y equal to double a, yes, it will work. See, this is your string. This is your candidate string. In this area, you need to find y. Okay, this is the candidate string. This is the candidate string. And you have to find y in this area. In this area, you have to find y. Okay, find y. Now, let me take this y. Let me take this y. Okay, so I am taking this as y. So if I take this as y, what is x? You just tell me what is x. You tell me what is x. X is equal to double a. Okay, your y is also equal to double a. And what is your z? Z is equal to a. Now you tell me. Okay, let's do some powers. So tell me x y power 0 z. What is that? X y power 0 z. What is that? That will be triple a. Does it belong to L? Yes, it belongs to L. Yes, it belongs to L. You tell me what is this? This will be the same string. Yes, it also belongs to L. Okay, let's do this. What you will get? This is your x. And this is your y. And this is your z. This is your a power 7. And this also belongs to L. Did you notice? Did you notice? Whatever power I take, that will belong to L. Whatever power I take, that will belong to L. That will belong to L. Okay, yes or no? Is this clear? So remember, if you take this p equal to, remember your language is what? Your language was a power 3, a power 5, a power 7, and so on. This was your language. And can you notice, if you take p equal to 4, that will work. That work. Yes or no? That will work. Can you notice? Tell me, in any string, see, these are the candidate strings. I can say these are the candidate strings. If you take any candidate string, let's assume you take any candidate string. For example, let me take a power 7. Okay, if you take any candidate string, let me take a power 7. Tell me which y will work. This is your candidate string. I am taking this candidate string. So in this area, you will find y. You will find y in this area. In this area, you will find y. So tell me which y you will take. You can take y equal to double a again. Always take y equal to double a. Who is stopping you? For every string, just take y equal to double a. Just take y equal to double a. Okay, now you tell me. If I repeat this 0 times, now if I take y equal to double a, so what I have done, I have taken y equal to double a. Tell me what is x. X is left of y. And what is z? And z is right of y. So tell me, if I repeat it 0 times, what I will get? If I repeat y 0 times, I will get a power 5. That belongs to L. If I repeat this y 2 times, what I will get? I repeat it 2 times, I will get a power 9. That belongs to L. So did you notice that I can repeat this y any number of times. I can repeat this y any number of times. The result will belong to L. I can repeat this y any number of times. The result will definitely belong to L. Yes or no? So P equal to 4 will work. Is this clear? P equal to 4 will work. The point is simple. All you have to do, whatever string you have, this is your string, this is your candidate string. All you have to do in this area, you have to find y. Okay, just take this equal to y. This y works. Whatever candidate string you take, whatever candidate string you take, just take this y. This y will always work. Okay, is this point clear? So I can say P equal to 4 is working. Isn't it interesting? Tell me this example. Did you find this example interesting? Some students were thinking P equal to 4 will not work, P equal to 5 will work. Yes or no? Some students were thinking that P equal to 4 will not work, P equal to 5 will work. But this example, you can see this is quite interesting that P equal to 4 is working. So P equal to 5 will also work. Agree with me? P equal to 5 will also work, P equal to 6 will also work. Okay, so very simple. So this is your example. Now in this example, what I can say? I can say that P equal to 4 works. Means if you take P equal to 4, for P equal to 4, I can say every candidate string is pumping. Every candidate string pumps. Every candidate string, it pumps. Okay, so quite simple. And this is what we want. For P equal to 4, every candidate string pumps. That's it. This is what we want. So I can say L satisfies pumping lemma. L has passed pumping lemma. The test of pumping lemma. The exam of pumping lemma. So L has passed exam of pumping lemma with how many marks? With P equal to 4 marks, or I can say with this. Okay, with this. Minimum pumping length will be 4. Minimum pumping length will be 4. So this will be your answer. So remember, for this language L, if someone asks you pumping length, what you will say? For this language L, if someone asks you pumping length, what you will say? If someone asks you pumping length, then the answer will be greater than or equal to 4. Answer will be greater than or equal to 4. And if they ask you minimum pumping length, then the answer will be 4. Okay, so this is your one example, quite simple, quite interesting example. Let me tell you one thing, your GATE 2019 question that is similar to this. Okay, GATE 2019 question that is similar to this example. Similar, very similar. You can check it out. Your GATE 2019 question that is very similar to this example. But don't worry, that question we will solve in class. In lecture we will solve. Okay, but you can check if you want. Okay, after the class you can check. So this language we have seen. That's it. Now let's move on now. Now let's see some more examples. Now let's see one very interesting example. Let me take example number 4. In the last class, we have seen 3 examples. Now let's see example number 4. Very interesting example I am going to take. This language. Okay. Language is A power n, B power n. Before we see this language, you tell me what is n? In theory of computation, in TOC, in automata theory, if I give you this, then what n you will take? Is n greater than equal to 0? Is n greater than equal to 1? What n you will take? Like greater than equal to 10? What n you will take? If n is not given, I have not given you n. Let me tell you why I did not give you n. What is the reason I did not give you n? Because in Ullmann book, this is written. If you read this Ullmann book, there is one line written. One line. Okay. So somewhere you can find this line that in automata theory, if the power, for power, this is the power, yes or no? This is the power. For power, for exponent, if range is not given, then this is the considered range. Okay. In this Ullmann book, this line is written that for exponents, if range is not given, if range not mentioned, for exponent means power. Exponent means power. So for exponents, if range is not mentioned, then the by default range, what is that? Then by default, the by default range then by default, this power is greater than equal to 0. Okay, this simple point I want to tell you, this is nothing like, for example, I can say, it will not matter to you because in the GATE exam, they will mention everything will be given to you in the GATE exam, but this is just a simple point. Okay, so you can see if range of power is not given, this is a power, this is a power. If range of power is not given, then by default range is greater than equal to 0. Okay, and this statement is actually given in the Ullmann book. You can check it out. But anyway, this is just, you can take it for granted. Now let's see. Now let's see this language. Does it satisfy pumping lemma test? Does it satisfy pumping lemma test? This is interesting question. Very interesting question. Okay. So let's check. Does this language L satisfy? Will it pass the pumping lemma exam? Will it pass the test of pumping lemma? Okay. Let's check. You tell me one thing. What is the starting point of pumping lemma? The starting point of pumping lemma. The starting point of pumping lemma says there is a magical number. Yes or no? There is a magical number. The starting point of pumping lemma. See, we want to check this language has magical number or not. This is what we want to check. We want to find out this language, does it have some magical number? Okay. So will it satisfy this language? Will it satisfy the test of pumping lemma, the exam of pumping lemma? Now let's see. So let's start with p equal to 4. Will p equal to 4 work? First of all, you understood the language that is given to you. This is the language a power n, b power n, where n is greater than equal to 0. So tell me, what are the strings in the language? If you put n equal to 0, then this will be empty string. If you put n equal to 1, if you put n equal to 2, then you will get a square, b square. If you put n equal to 3, you will get a cube, b cube, a power 4, b power 4. This type of strings you have in the language. Okay. This is what you have in the language. Very simple. This is your language. So first you understand the language that is given to you. Okay. Now tell me the next thing. So let's see. Does p equal to 4 work? Let's check it out. Okay. So take your copy pen. Take your copy pen. Okay. So for this language p equal to 4, let's check. Does it work or not? So you tell me, first of all, what will be your candidate strings? Okay. Forget about everything else. You just tell me what are the candidate strings. You just tell me what are the candidate strings. Remember, these strings matter to us. Yes or no? These strings can violate or they can satisfy. See this line, remember, only these strings can violate or they can satisfy. बनाएंगे भी यही, बिगाड़ेंगे भी यही, something like that. You know, there is a line. Okay. Salman Khan dialogue or something like that. See, बचाएंगे भी हम, मारेंगे भी हम, बचाएंगे भी हम. So something like that. See, only these strings matter. We only care about these strings. These strings have the power to violate and these strings have the power to satisfy. Either these strings will pump or some of these strings will not pump. Okay. Yes or no? So what are the candidate strings? Because I am taking p equal to 4, so my candidate strings will be a power 2, b power 2, a power 3, b power 3, a power 4, b power 4. These will be my candidate strings. Okay. Yes or no? Very simple. These are going to be my candidate string. Now let's check this p equal to 4. Okay. Let's check it on a power 3, b power 3. Let's directly check it on a power 3, b power 3. So, okay, let's check this a power 3, b power 3. Okay, this is your candidate string. I have taken candidate string. First of all, you tell me in which area you will find y. In which area are you going to find y? You will find y in this area, in the first 4 symbols. In this area, you will find y. These are the first 4 symbols. These are the first 4 symbols. Okay, in these first 4 symbols, you find y. Okay, right? So you tell me, is there any y which you can take, you can repeat, and the result will belong to L? Which y you can take? Some students are saying y equal to AB. Some students are saying y equal to AB. Okay, some students are saying y equal to AB. Let's check. Will this y work? Okay. Let me check. Will this y work? Let's assume this is the y. Let's assume this is the y. Then what is x? Tell me what is x. X is AA. What is z? Z is BB. Now you tell me, if I repeat this y 2 times, what I will get? If I repeat this y 2 times, what I will get? Tell me what will be this? X, Y square Z. What that will be? Can you notice that will be double A? That is your X. That is your X. And then AB, AB, and then BB. Correct? Does it belong to L? Does it belong to L? If I repeat this Y 2 times, the resulting string does not belong to L. So this Y will not work. If you are thinking this Y will work, no, this Y will not work. So tell me, give me some other Y. Some other Y which can work. Give me. Can anyone give me some other Y? See, this Y will not work. I can promise you this Y will not work. Okay, let's check. For example, will this Y work if I take Y equal to A? Okay, if I take Y equal to A, will this work? This will also not work. This will also not work. Tell me why this will not work. If I take Y equal to A, I repeat it 0 times. Okay, just check this. I repeat it 0 times. That will not belong to L. I repeat it 0 times. That will not belong to L. So this Y is also not working. So tell me, will this Y work? Will this Y work? Will this Y work? Again, just repeat it 0 times. The result will not belong to L. Okay. Will this Y work? Will this Y work? Again, you repeat it 0 times. The result will not belong to L. You can try whatever Y you want. Tell me which other Y I can try. Just give me the idea. Which other Y I can try. For example, you can try double AB. This Y you can try double AB. Again, if you repeat it 0 times, the result will not belong to L. If you repeat it 0 times, it will not belong to L. So can you notice whatever Y I take, you can take whatever. You can take whatever Y you can take. They will not work. Is this point clear? So there is no such Y. We have no such Y. So can I say this string will not pump? This string is saying I will not pump. Yes or no? Agree? If you take P equal to 4, this string is shouting, I will not pump. Agree? So you can easily notice that. You can easily notice that for P equal to 4, if you take P equal to 4, then this A power 3, B power 3 will not pump. Will not pump. Or I can say this will violate. Whatever you do, it will not pump. Okay, it will not pump. I can say, so if you take P equal to 4, this candidate string will not pump. This candidate string will not pump. So can I say P equal to 4 does not work? Can I say P equal to 4 does not work? Yes. So I can say P equal to 4 not working. It is not working. So can I say no value of P will work? If P equal to 4 is not working, then we have to check some other value of P. Yes or no? Some other value of P we will have to check. But let me actually tell you one more point. Actually, this will also not pump. If you take P equal to 4, if you take this P equal to 4 and you take this string, AABB, this string will also not pump. Sorry, this string will actually pump. Oh, yeah, this string. Will it pump? Just check. Will this string pump? If you take P equal to 4 and you take this string if you take, this will also not pump. You can check. Okay, if you take Y equal to AB, then what will be the problem? Then what will be the problem? Tell me. If you repeat it 2 times, problem will happen. If you repeat 2 times, then problem will happen. If you repeat 2 times. Okay, if you repeat 2 times, then resulting string will not belong to L. So remember, if you take Y equal to 4, this will violate, this will also violate, every string will violate. Yes or no? So P equal to 4, if you take P equal to 4, I can say for P equal to 4, all these strings will violate. Every of them. Remember, each candidate string violates. String violates. Is this point clear? Please tell me. Is this point clear? You can notice here you can take whatever Y you take. See, I am just checking Y equal to AB, but there are other possibility for Y. Yes or no? There are other possibility for Y. For example, if you take this entire string as Y, because your P equal to 4, so you can take this entire string as Y. Then what will be the problem? Tell me. If you take this entire string as Y, will there be problem? Yes, again power 2 will be the problem. again the power 2 will be the problem. Remember, what is the power 2? If you take this entire string as if you take as y, then what will be power 2? Then power 2 will be AABB, AABB. This does not belong to L. This does not belong to L. This string does not belong to L. This string, this does not belong to L. So anyway, the point, did you understand? So whatever y you take, okay, whatever y you take, that does not work. So either you take this y or whatever y. Or whatever y you take. Definitely I can say that that will not work. Is this point clear? Okay, yes or no? Now you tell me one more thing. Will p equal to 5 work? Will p equal to 5 work? For p equal to 5, what are the candidate strings? Let's check for p equal to 5. Tell me the candidate strings. What are the candidate strings? Which strings I care about? I care about only these strings whose length is greater than equal to 5. Whose length is greater than equal to 5. I only care about these strings. I only care about these strings. If I take p equal to 5, then I only care about these strings. Okay, this time just take this because p equal to 5. So this is a power p, b power p, yes or no? Did you notice? This is a power p, b power p. If you take p equal to 5, this is just a power p, b power p. Okay, let's take this time. Okay, so just take this a power p, b power p. Now you tell me, this is your w that I am taking. In which area you will find y? P equal to 5. This is your w. This is your w. In which area? In this area you will find y. In this area you are going to find y. Now you tell me. Now something interesting. Something interesting. In this language, the given language has number of a equal to number of b. Agree with me? The given language has number of a equal to number of b. The given language is a power n, b power n. Okay, notice what is the given language? Let me write here. If you notice the given language, that is a power n, b power n, means number of a is equal to number of b. You tell me one thing. Whatever y you take, if you repeat 0 times, in the resulting string, number of a, number of b, what will be the connection between them? Did you understand? Find y. Find y in this. Now I am saying that whatever y you take, whatever y you take, remember y is always non-empty. Remember y is always non-empty. I am telling you whatever y you take. I am telling you whatever you take this y, you take this y, you take this a, whatever y you take, whatever y we take, tell me what will happen. If we repeat 0 times, if we repeat 0 times, what will happen? Tell me. If we repeat 0 times, then in resulting string, what is going to happen? Then in resulting string, what will happen? In the resulting string, I can say number of a that will definitely be less than number of b. Do you agree with me? Do you agree with me? Number of a will definitely be less than equal to number of b. See, let me give you the point. Let me give you y. For example, this is your string a. Okay. See, let me just tell you why I am saying this. Because this is your string 5a and then 5b. And we are checking p equal to 5. We are checking p equal to 5. We are checking. This is your string. This is your string w. Now, in this area, you will find y. This is the area in which you will find y. Okay. Now you tell me. For example, if I take y equal to a. For example, if I take y equal to a. See, in this area, you are finding y. Now, if you take y equal to a and I repeat 0 times, what is the resulting string? I repeat 0 times. Tell me the resulting string. Tell me the resulting string. The resulting string, if I take y equal to a, I repeat it 0 times. Repeat 0 times means this is gone. Repeat 0 times means this is gone. So the resulting string will be a power 4, b power 5. Does it belong to the language? This does not belong to the language. Because you can notice number of a is less than number of b. Similarly, if I take y equal to double a, and again the same thing, 0 times, repeat 0 times, repeat 0 times, then tell me the resulting string will be a power 3, b power 5. That also does not belong to L. If I take y equal to triple A, again I repeat 0 times, then the resulting string will be a power 2, b power 5. That also does not belong to L. Did you notice whatever y I take, the resulting string, if you repeat 0 times, the resulting string will have number of A less than number of B. See, whatever y I take, this is what I'm telling you. I'm telling you whatever y you take, 0 times you repeat, 0 times you repeat, what will happen? Tell me what will happen. You will get something like this. You will get a power m, b power, you will get a power n, b power 5. Tell me what will be this n? What if you repeat 0 times, you will get a power n, b power 5. And here actually you can notice this n will be less than 5. This n will be less than 5. So this n will be less than 5. So that is the reason I can say, this does not belong to L. So did you understand? Whatever y you take, that will not work. So whatever y we take, if we repeat 0 times, then in the resulting string, number of A will be less than number of B. So resulting string does not belong to what? So resulting string does not belong to L. So there is no y, yes or no? Agree? So for p equal to 5, I can say, so for p equal to 5, if you take p equal to 5, for p equal to 5, this string a power 5, b power 5, this is basically a power p, b power p. This string is saying I will not pump. Okay, for p equal to 5, this string is saying this string will not pump. Will not pump. Means there is no such, there is, I can say, there will be no y. No y exist. Agree? Yes or no? This string will say, I will not pump. This string will not pump. So if this string is not pumping, then I can say p equal to 5 does not work. Yes or no? P equal to 5 does not work. So this will not pump. So p equal to 5 does not work. So I can say, remember, p equal to 5 will not work. Not working. So p equal to 4 is also not working. P equal to 5 is also not working. You tell me, okay, let's take this. Let's not take one by one. See, p equal to 4 is not working. P equal to 5 is not working. Now let's directly take p equal to 20. Will it work? Let's directly take p equal to 20. Tell me, will it work? Let's check p equal to 20. Will it work? It will also not work. Okay, for p equal to 20, can I say this is a candidate string? A power p, b power p means this a power 20, b power 20. Is this a candidate string? Tell me, does this string have the power to violate or satisfy? Is this the powerful string? This string has the authority. This string has the authority to satisfy or violate. Remember, this is a candidate string. One of the candidate string. This is one of the candidate string. Okay, one of. Now you tell me. In this, so this is your a power 20. A power 20 and b power 20. Okay, this is your string W. Now, in which area you will find y? Tell me, in which area are you looking for y? This is your entire string. This is the entire string. But because you are taking p equal to 20, so you will find y in the first 20 symbols. The first 20 symbols have only A's. Yes or no? In the first 20 symbols, you have only A's. These are the first 20 symbols. These are the first 20 symbols. In these first 20 symbols, you will find y. Okay, here you find y. Tell me one thing. Whatever y I take, whether I take y equal to a, y equal to double a, y equal to triple a, y equal to a power 20, whatever y I take, if I repeat 0 times, what will happen? Just tell me this point. See, whatever y you take, whatever y, if you repeat 0 times, what will happen? Tell me. If you repeat 0 times, in the resulting string, what will happen? In the resulting string, what is going to happen? In the resulting string, number of A will definitely be less than number of B. Number of A will be less than equal to will be less than number of B. Yes or no? In the resulting string, this will happen if you repeat 0 times. If you repeat 0 times, then this will happen. Number of A will be less than number of B. So what I can say? So this resulting string does not belong where? So this resulting string. So this resulting string does not belong to L. Remember, whatever you take, whatever Y, okay, whatever Y you take, the resulting string does not belong to L. So what I can say? So this string is not pumping. Yes or no? So I can say if you take for P equal to 20, for P equal to 20, what this string is saying? A power P, B power P. That means A power 20, B power 20 will not pump. Will not pump. This string is basically violating. Okay, so P equal to 20 is also not working. See, P equal to 4 not working, P equal to 5 not working, P equal to 20 not working. Is there any P which will work? Is there any P? Is there any P that will work? P equal to 20 is also not working. Is there any magical number P which will work? Let me tell you the general solution. So far, we did not see the general solution. Okay, just to explain, I am going step by step. Okay, you might be thinking, why are we taking any P equal to 4, P equal to 5, P equal to 20? That is just to explain so that you understand very clearly what is happening. Okay, but now let's see the general solution. Tell me one thing. If I want a general solution, will I take a specific value of P? If I give you general solution, will I take some specific value? Will I check some specific value of P? No. Specific value I have already checked. P equal to 20, P equal to 4, P equal to 5. Specific value I have already checked. Okay, so now I will not take a specific value. Now I will assume there is some P. Maybe that P is 1 trillion, 1 billion. I don't know. Maybe that is 10,000. Yes or no? I don't know what is that P. Let me assume there is P. Is this point clear? Is this point clear? Tell me. Let me assume there is P. I am still hopeful. Okay. I did not lose hope. I am still thinking that maybe this has a magical number. Is this point clear? I am still thinking that maybe this has magical number. Okay. So assume there is a magical number. Assume P works. Okay. Assume this magical number P works. I am saying, let's assume there is a magical number. I don't know what is that magical number. Maybe 10,000, 1 trillion, 1 billion, whatever. Assume this magical number P. Okay. Remember, this P can be anything. I don't know. Okay. I'm just assuming there is some P. Okay. This can be a very big number. I don't know. But the point is, assume there is magical number P. Now tell me who will, now tell me the candidate string which will violate. As soon as you will take this magical number, give me a candidate string who will come and who will say that, okay, I will violate, I will not pump. If you take this P, this can be any magical number P, then give me a candidate string who will say that I will not violate. Yes, that is A power P, B power P. Okay, just to take this directly, just to take this A power P, B power P. First of all, you tell me, is this candidate string or not? Does this string has the authority? This string, does it have the authority? Yes, this has the authority because this belongs to L and its length is also greater than equal to P. So remember, this has authority. Remember, this has authority. Okay. So this is your candidate string. Now you tell me, will it violate? This candidate string, will it violate? So take this W equal to this. Now let me tell you, this will violate. For example, this is your A power P, B power P. Okay. So this is the string. This is the entire string. This is your entire string. Remember, we are checking P. We are checking pumping length. What is the pumping length we are checking? Which magical number we are checking? We are checking magical number equal to P. This magical number we are checking. Okay. So this is what we are checking. Pumping length equal to P. In which area you will find the Y? In which area you will find the Y? In the first Y, in the first P symbols. These are the first P symbols. These are the first P symbols. In these first P symbols, you will find Y. But something interesting will happen. Something interesting will happen. If I take Y equal to this and I repeat 0 times, I take y equal to this. I repeat it 0 times. I repeat this. This is y. I repeat it 0 times. In the resulting string, how many a's will be there? If I take this as y, I repeat it 0 times. In the resulting string, how many a's will be there? Number of a's in the resulting string, that will be p minus 1. So I can say number of a's will be less than number of b's. Yes or no? If I take this if I take as y, then also if I repeat 0 times, then also what will happen? Number of a will be less than number of b. So the point is simple. The point is simple that whatever y you take, the point is simple. Whatever y you take, if you repeat 0 times, what will happen? If you repeat 0 times, what will happen? If you repeat 0 times, in the resulting string, number of a will be less than number of b. Number of a will be less than number of b in the resulting string. In the resulting string, this will happen. So what can you say? So this result does not belong to what? This result does not belong to L. This result does not belong to our language, because our language is a power n, b power n. So this result does not belong to our language. Remember, whatever y you take, this string is not pumping. You can take whatever y you want. You repeat it 0 times, then you can notice the resulting string will not belong to L. So what I can say, tell me what I can say. So I can say, so no y exists. So there is no y exist. Means I can say for p, this string will not pump. This string is not pumping. This string will not pump. Okay. Now I can say, notice one thing. So notice one interesting thing. Did you notice there is no magical number? See, no magical number is working for this L. No magical number is working. There is no magical number that is working. There is no magical number that works. Actually, what is the problem? See, problem is not with the magical number. The problem is whatever magical number you take, there is a string who will say, I will not pump. Yes or no? Something interesting. See, no magical number that works. There is no magical number which working, because what is happening? See, whatever magical number you take, whatever magical number p you take, okay, then what will happen? There is a violating string. Okay, some string will oppose. Some string will say, no, many calorie. Okay, some string will say, okay, so I will not play. So you can see, whatever magical number you take, some candidate string will not pump. Some candidate string. And what is that string? Give me one such string. Some candidate string. For example, this string you can take a power p, b power p. Okay, whatever magical number p you take, this candidate string a power p, b power p will not pump. So whatever magical number you take, I can say there is at least one violating string. Yes or no? So I can say whatever, understand this. Okay, whatever pumping length you try, whatever magical number, or I can say whatever pumping length p we try, okay, I can say there is a violating string. There is a string which violates. There is a violating string. For example, this string violates a power p, b power p. Okay, that's it. So this is your, now I can say that for this language, there is no magical number. If this language has no magical number, what you can say about this? If this language has no magical number, what you can say about this? So this language has no magical number means it has failed pumping lemma. It has failed pumping lemma. If it has failed pumping lemma, what I can guarantee, it is definitely not regular. Yes or no? It is definitely not regular. Agree? This language has failed pumping lemma. So remember, this is definitely, this L is definitely, there is a guarantee that it is not regular. This L is definitely not regular. Okay. Is this point clear? So I can say this is the proof. This is called proof. We have proved it. This is called proof. Okay. Is this point clear? Let me know. Simple, right? Yes or no? So this is your proof. Now remember, in future, if someone asks you this a power n, b power n, this is not regular, which logic you will give? Will you say there is comparison, there is one comparison, finite automata cannot do comparison? This type of dumb logic will you give? Or will you say that whatever magical number you take, there is a violating string? Yes or no? This is the logic you can give. See, in interview, just think about it. There is a professor. There is a professor, and they ask you, is this regular or not? You will say non-regular. Then they will ask you why this is non-regular. Then some student will say, sir, there is one comparison, and in my notes it is written, that finite automata cannot do comparison, finite automata cannot do this, finite automata cannot do matching. Okay, finite automata this, that addition, multiplication, finite automata cannot do logarithm. Will you say this? If you say this, let me tell you what will happen. If you say this, what will happen? Definitely in this college you are not going. Okay, this professor is definitely not taking you. So very simple. The point is, you can say now you can prove it. And let me tell you one thing, I guarantee you. Okay, if you do not answer 3 or 4 questions, but if you can answer this question with pumping lemma, they will take you. They will definitely take you. Okay, one theory of computation professor will definitely take you, because he's not expecting that you will give this much concrete answer. You will give a formal proof. Okay, so anyway, the point is, you understood that this language fails pumping lemma. You understood this? Yes or no? Can I say this? You understood that this fails pumping lemma, and because this fails pumping lemma, so this is a non-regular. There is a definitely, this is a non-regular, because regular languages will never fail pumping lemma. Every regular language will pass pumping lemma. Okay, so this is the point. I hope this point you understood. One thing I just want to tell you, a small thing I want to tell you, because some student is asking, you tell me one thing, is this regular expression a power n, b power n? Is this regular expression? Is this regular expression? Is it regular expression? The answer is no. The answer is no. In regular expression, you cannot have variable power. Okay, this we have seen in the regular expression chapter. Yes or no? Do you remember? Repeatedly, I told you. If you remember, on this point, I have already put pressure on this point. Repeatedly, I told you that regular expression cannot have variable power. Regular expression can never have variable power. Variable exponent can never have variable exponent. Okay. In power, what in regular expression, in power, what you can write? Tell me. For example, in regular expression, what are allowed? In power, what is allowed? For example, in regular expression, you have this R. What are the things that are allowed? See, constant is allowed. Okay, you can say R power constant. For example, R power 2, that is allowed. R star is also allowed. See, this is not a power. This R star, is this a power? Is this a power? This is not power. This is one thing. Okay, this is not power. Okay, please understand. This is not power. This is one operation. So this R star, this star is not a power. This star is not a power. This entire thing is one thing. Okay, is this point clear? So remember, this star is not a power. But the point, okay, anyway, for simplicity, I am saying that our R power constant is fine. R star is fine. R plus is fine. R or S, fine. RS, fine. Okay, so these things are fine. Is this point clear? Tell me. Let me know. Okay, some student is asking, if this language has magical number, can I say it will be regular? If this language has magical number, then can I say it will be regular? Yesterday I told you, no. If you pass pumping lemma, can I say you are regular? No. I told you this in last class, that every regular language will pass pumping lemma, but there are some non-regular languages, they will also pass pumping lemma. So if I pass pumping lemma, it does not mean I am regular. Is this point clear? If a language is passing pumping lemma, you cannot say it is regular. But if a language is failing pumping lemma, if a language fails pumping lemma, then definitely that language is non-regular, because every regular language will pass pumping lemma. This we have seen in the last class. Okay, I hope this point is clear. All the points are clear. Now let's move on Now let's move on. You tell me this point. What does it mean when we say L fails pumping lemma? What does it mean? What does it mean when we say L fails pumping lemma? A language is failing pumping lemma. What does it mean? Before we look at this, you tell me what it means when I say L passes pumping lemma. L passes, L satisfy pumping lemma. What it means? What it means? If L is passing pumping lemma, it means there is a, see, if L is passing pumping lemma, what you can say? L passing pumping lemma, what that means? Okay, L pass pumping lemma, what that means? L is passing pumping lemma. Okay, L passes pumping lemma. This means there is a magical number. Okay, this means, let me tell you what this means. This means there is a magical number. Okay, this means there exists a magical number P, which is greater than or equal to 1. Okay, there is some magical number P such that every candidate string pumps. Such that every candidate string pumps. Every candidate string pumps. Yes or no? Do you agree with me? Yes or no? If you are passing pumping lemma, if L is passing pumping lemma, that means there is a magical number such that every candidate string will pump. Every candidate string will pump. Now you tell me, if L fails pumping lemma, what that means? Now you tell me, if L fails pumping lemma, what that means? If L is failing pumping lemma, what that means? That means whatever value of P you take, that means whatever P you take, that means whatever P you take, for every P, there is some candidate string who does not pump. Agree or not? There is some candidate string who does not pump. Do you agree with me? Did you notice? Is this clear? Does not pump. See, please understand. Again, I'm telling you, please focus here. If L is passing pumping lemma, if L satisfies pumping lemma, that means there is a magical number. There is some magical number such that every candidate string will pump. Okay. So tell me, if L is failing pumping lemma, what that means? If L is failing pumping lemma, tell me what that means. Tell me what that means. That means whatever P you take, whatever magical number you take, whatever number you take, you will always find some string who will say, I will not pump. This we have seen in the A power n, B power n also, if you remember. In this language, A power n, B power n. In this language also, the same thing we have seen. For this language, we have seen whatever P you take, whatever P means, that means for all P. Yes or no? Whatever P means for all P. Okay, so for every P, what was happening? Tell me. For every P, this candidate string was not pumping. A power P, B power P. This is some candidate string which is not pumping. This string not pumping. Whatever P you take. Yes or no? Agree or not? Please tell me. For this language, we have already seen whatever value of P you take, for every value of P, what will happen? This string will say that I am not pumping. So I can say L is failing pumping lemma. So this language L fails pumping lemma. So remember, L fails pumping lemma. That means for every value of P, whatever number you take, whatever magical number you take, some string will say, I will not pump. Tell me, some string will say or every string will say? Tell me, some string will say or every string will say? Some string violates. Okay. So for every P, some string will violate. Okay. So this is what it means. So what does it mean when you say a language is failing pumping lemma? Remember, it means, okay, it means for every P, there exists candidate string W. There exists a candidate string W who does not pump. Who violates? Who violates? Okay, yes or no? So whatever P you take, for every P, there exists some candidate string who will violate. So that's it. This is the point. Now let's move on now. Now let's see this. So you tell me one thing. If you already know that L is regular, then the question will ask you what? Like in the GATE 2019, the regular language was given to you. If you already know L is regular, if you already know, then the question will ask you pumping length. Yes or no? If the language is regular, if the language is already regular, if you know that language is already regular, then they will ask you pumping length. So this is what I'm saying. If the language is already regular, then just find the pumping length. Just only find the pumping length. And if they ask you, then find the minimum pumping length. Okay, very simple. And now tell me, if you want to prove that L is not regular, then what you will do? If you want to prove that L is not regular, then what you will do? Then you will show that whatever magical number I take, for every magical number, there is a violating string. There is a violating string. There is some violating string. Correct? This slide is important right now. This slide that you are looking at, this slide is important. Please read this and tell me, did you understand this? If you want to prove L is non-regular, then what you can do? Then you can show that whatever magical number I take, whatever P I take, don't take a specific P, yes or no? Don't take a specific P. For example, don't check P equal to 20, P equal to 30. Take whatever P, means take just P. This P you take, just take this P. So whatever P you take, there is always some violating string. There is some string who will say, I will not pump. Okay, so that is the point. Now let's take another question. Example number 5. Okay, so this is the last example we will do. This is interesting. Let's quickly do this. So tell me the answer for this. This language is given to you. The alphabet is 0, 1. And the language is saying that W has equal number of 0 and 1s. W has equal number of 0 and 1s. Okay. So first of all, you tell me, is this the language same as your previous language? This language, is it same as the A power n, B power n? No, this language is not same as A power n, B power n. Okay. So remember, this language is given to you. Your language, now your language B, that is your language. You can notice this language is given to you, that is B. So this language has this type of string, number of A equal to number of B. You have those strings such that number of A in W is equal to number of B in W. Okay, this type of strings you have, means you have this type of string. This string is there, this string is there, this is also there. For example, AB, that is also there. AA, BB, that is also there. BB, AA, that is also there. BA, BA, that is also there. BAA, B, that is also there, and so on. Okay, so these are the strings. Okay, now let's see. For this, let's prove. First of all, does this satisfy pumping lemma condition? This language, will it pass pumping lemma test? The test of pumping lemma, will it pass? The test of pumping lemma. Some students are saying that for this language, regular expression is 0, 1 star. Is that correct? For this language, see, some students are saying this is your language. Remember, your language is W, such that number of zeros in W that is equal to number of ones in W. Okay, so tell me, can I say for this regular expression is correct? 0, 1 whole star. Is this correct? No, this is wrong. No, this is wrong. Why this is wrong? Because you can notice this string also belongs to L. Notice this string also belongs to L. See, this string belongs to B. This string belongs to this language B. This string belongs to the language B. But this string cannot be produced by 0, 1 whole star. Not produce, not generate. Not generated. Okay, this will not generate this. Is this point clear? So you can notice this regular expression is wrong, because this regular expression will only give you this type of strings. Only this type of strings you will get. Only this type of strings you will get. But you will not get this type of strings. So this regular expression is wrong. Is this point clear? What is this language? Did you understand what is this language? Number of 0 is equal to number of 1. Here number of 0 is 3. Here number of 1 is also 3. So this string belongs to the language B. So first you understand the language. Okay, now you tell me. Okay, let's directly check. Then first you tell me, just tell me this. P equal to 3, will it work? For this language, this is your language W, such that number of zeros that is equal to number of ones. And your alphabet is 0, 1. Now let's check. Will this P equal to 3 work? Can you give me a violating string? Is there anyone who wants to give me a violating string? Give me a candidate string which will say, I will not pump. I will not pump. Give me a candidate string which will say, I will not pump. Okay, so I can again give you that same 0 power 3. Just take this 0 power P, 1 power P. Means 0 power 3, 1 power 3. Take this, take this, take this. Will it violate or not? Just take this. Okay, for a moment, just take this. Will it violate or not? Means this is your string 0, 0, 0, 1, 1, 1. This is your string. Let's check, will it violate? This string, will it say, I will not pump? Remember, this is your P. I am checking P equal to 3. So now what you do, you take this string. You take this string. First of all, is this a candidate string or not? First you tell me, this string, does it have authority? This string, does it have authority to violate or satisfy? Yes, this is a candidate string because this string belongs to the language and its length is greater than or equal to 3. So remember, this is a candidate string. Okay, this is a candidate string. Now you tell me. So in which area you will find Y? This is your string W. In which area you will find Y? You will find Y in this area. In this area, you will find Y. These are the first P symbols. These are the first P symbols. P means 3. This P is equal to 3. So these are the first 3 symbols. So in this area, you will find Y. Now, again, can you notice something beautiful? Whatever Y you take, if you repeat 0 times, the resulting string, will it belong to L? Whatever Y you take, for example, you tell me one thing. If I take this Y and I repeat it 0 times, what will be the resulting string? If I take this Y, I repeat it 0 times. 0 times means this is gone. This is gone. The resulting string does not belong to L. Okay, so did you notice? For this length, if you are checking P equal to 3, this is what we are checking. And you can notice, look at this string 0, 0, 0, 1, 1, 1. Look at this string. I am saying that in this area, you find Y. In this area, we will find Y. But something interesting is happening that whatever Y you take, you can take whatever Y you want. If I repeat 0 times, please tell me what will happen. If I repeat this 0 times, whatever Y you take, if I repeat it 0 times, in the resulting string, what will happen? In the result string, what will happen? I can say number of 0 will be less than number of 1, right? Number of 0 will be less than number of 1. Number of 0 will be less than number of 1. Okay, whatever Y you take. For example, if I take this entire Y, then what will be the resulting string if I repeat 0 times? I take this equal to Y. I take this equal to Y. I repeat it 0 times, then resulting string will be 111. Okay, so very simple. The point is, whatever Y you take, if you repeat it 0 times, the resulting string has number of 0 less than equal to number of 1. So what is happening? Tell me. So this resulting string, does it belong to L? So this resulting string, does it belong to L? Tell me. So this resulting string does not belong to L. Your language is B. So it does not belong to B. So the resulting string does not belong to the language B. Okay. Whatever Y you take, this is important, that whatever you can take, whatever Y you take, this will not happen. So you tell me, there is no Y, yes or no? So can you notice P equal to 3 will not work? So notice that for P equal to 3, if you take P equal to 3, then this 0 power P, 1 power P, this 0 power P, 1 power P, this does not pump. This string is saying that I will not pump. Yes or no? This string does not pump. And some string is not pumping. For P equal to 3, some candidate string is not pumping. So what I can say? So I can say P equal to 3 not working. Yes or no? So P equal to 3 is not working. Now you tell me, just directly you tell me, will any P work? Will any P work? Is there any P which will work? Is there any number which will work? Let's see the general solution. Now I will give you the general solution directly. See the general solution. You know your language. Your language is number of 0 equal to number of ones. Number of 0 that is equal to number of ones. This is your language. Okay. Now in this you can see whatever P you take. Okay, just take any P. Whatever P you take, what will happen? You take whatever P you want. Just take whatever P you want. What will happen? Whatever P, whatever value of P you take. This P can be 10,000, 10 crore, 1 trillion, anything. Whatever P you take. There is one string. There is a candidate string. See, there can be more also. Tell me, 0 power P, 1 power P. Is this the only candidate string which will say that I will not pump? No, there can be more also, but we are interested in only one candidate string. Yes or no? Remember, we only care about some string which is not pumping. Some string is not pumping. That is what we care about. We don't care about other strings. There can be more strings who can violate. Okay, other than 0 power P, 1 power P, there can be other strings who can violate. Okay, but the point is simple that whatever P you take, this 0 power P, 1 power P will violate. And remember, first of all, you tell me, does it have authority? Is this a candidate string or not? Yes, this has authority. So this matters. This 0 power P, 1 power P, this matters. And if this is angry, then I can say there is a problem. Yes or no? This matters. It is like Chacha Mama. Sorry, Mama are always good. You know, maternal uncle, they are always good. So this is like Chacha Tau, something like that. Okay. So anyway, you can see they matter. And they are angry. Okay, they are angry. So there is a problem. So you can easily notice that this is your candidate string. And this candidate string will say, what this string will say, tell me. This string will say, I will not pump. I will not pump. This is in every wedding, there is at least one string. Yes or no? Whatever wedding you take, whatever P equal to wedding, whatever wedding you take, there is at least one. There is at least one Chacha Tau who will say, I will not pump. Okay, anyway. Now, Fumfaji, yes. Kakaji, Fumfaji. Someone is there, or Jizaji. Okay, how can you forget Jizaji? Okay, so anyway, the point is simple. So now let's move on. So is this point clear? Tell me. So whatever P you take, this candidate string will not pump. So tell me. So this language has failed pumping lemma, yes or no? This language B failed pumping lemma. Failed pumping lemma. This language B failed pumping lemma. So this is the point. Now you tell me, if this language has failed pumping lemma, what can you say about this language? Just tell me this point. What can you say about this language where number of zeros are equal to number of ones? Where number of zeros are equal to number of ones. What can you say about this language? This language has failed pumping lemma. In the pumping lemma test, this language has failed. Backlog. So you tell me, if it has failed pumping lemma, that means this language is definitely non-regular. That means this language is definitely non-regular. B is non-regular. Yes or no? Yes or no? This language is definitely non-regular. Okay. How it is failing pumping lemma? Tell me. Failing pumping lemma. What that means? Failing pumping lemma, that means for every P, whatever magical number you take, for every P, there exists a W who will not pump. There exists a W such that W does not pump. Such that W does not pump. Okay, means W is violating. So this is what it means. I hope now you are expert of pumping lemma. Did you understand? Are you confident in pumping lemma? So remember, this language is non-regular. This language is not regular. Some students were asking, what is the regular expression for this language? So tell me, what is the regular expression? Tell me, what is the regular expression? What will be the regular expression? If it is not regular, then there is no regular expression. So for this language, regular expression does not exist. Does not exist. Because if you have regular expression, then it will be regular language. Yes or no? If this language has regular expression, then it will be regular language. But this is a non-regular language, so regular expression does not exist. There is no regular expression which can describe this language B. Remember, there is no regular expression. You cannot write any regular expression which can describe this language B. Okay, is this point clear? Tell me. So this is your session. Now let me know, did you understand so far? So far everything that we have seen, please tell me, did you understand? This pumping lemma, is this on your fingertips? Can you say that? Yeah, pumping lemma matlab kya hai isme? You know, easy sa to hai. You know, nowadays there is a famous auntie, you know, kya hai pumping lemma? Lappu sa pumping lemma. Okay, yes or no? So something like that. So can you say that? Kya hai pumping lemma? Lappu sa pumping lemma hai. Okay, yes or no? So today you can write in your notes. You can write that Lappu sa pumping lemma. No, pumping lemma is not over. Some students are asking pumping lemma is over. Is pumping lemma over? No. We have to see the proof. But the point is, whatever we have seen so far, that matters. I'm just telling you this point. In your GATE exam, in any exam, whatever we have seen so far, whatever we have studied so far, that matters. Okay. Your marks will come from this. But don't worry, this pumping lemma is not over yet. We have to see the proof. Then we will have to see the questions which are based on the proof. Okay, so there is something remaining. But before going to the next lecture, let's solve this question. Okay, let's solve this university question. You will get 2 points. This is a nice question from a top university. You are going to get 2 points if you solve it. Let's solve this question quickly. Now you are expert, remember. Now you are expert. So tell me, we can use the pumping lemma in order to prove that this language is not regular. Okay, this question is saying, see, we can use pumping lemma in order to prove that this language is not regular. The proof will start like this. How the proof will look? How the proof will start? The proof will start, if this is regular, see, the proof will start like this. If this is regular, there must be a there must be a magical number. Agree or not? Agree or not? If this is regular, see, if this is regular, then there must be a magical number. Do you agree with me? Do you agree with me? If this is regular, let's assume this is regular. Let's assume for a moment, let's assume this is regular. If this is regular, then there must be a magical number. So let's assume P is the magical number. Let's assume P is the magical number for this language. Then we choose the string. Okay, so this complete thing is not given. Now you tell me, which of the following string would be good candidate string? Which of the following will be the good candidate string to choose? Means which strings will help you prove that this is non-regular? This is what the question is asking. Did you understand the question? The question is asking, which string will help you prove that? The question is asking, which candidate string will help you prove that this L is non-regular, that L fails pumping lemma, that L fails pumping lemma. Hence L is non-regular. Hence L is non-regular. Okay, so this is what the question is asking. Did you understand the question? First you tell me, did you understand the question? Please tell me the question. Did you understand? This language is given to you. We want to prove, remember, we are using pumping lemma to prove that it is not regular. Okay, now, so if you take P is your pumping length. If you take P is equal to pumping length, then which candidate strings will help you prove that L is failing pumping lemma? If L fails pumping lemma, then what you can say about L? If L fails pumping lemma, what can you say about L? That it is a non-regular. So this is the question. Okay, already P is given to you. This P is the pumping length. Already it is given to you. So tell me which string will violate? Which string will violate? This language is A power 2I, B power I. First of all, you understand the language. Before solving the question, first of all, understand the language. A power 2I, B power I. That is I greater than equal to 0. Okay, tell me the strings in the language. Before solving this question, tell me the strings in the language. This is your language. A power 2I, B power I. If I take I equal to 0, what I will get? If I take I equal to 0, A power 0, B power 0, that is empty string. If I put I equal to 1, then I will get this. If I put I equal to 2, then I will get this. If I put I equal to 3, then I will get, if I put I equal to 3, I will get this. I equal to 4, I will get this. So number of A is double than number of B. Yes or no? It's something like this. Number of A, that is basically double of number of B. And you can notice after A, B are coming. Okay, so this is your language. So first you understand the language. Now let's solve it. Okay, let's see this. A power P, B power P. Will it violate? Let's start with A power P, B power P. So this, remember your pumping lemma, your pumping length, what we have assumed? What pumping length we have assumed? Pumping length that we have assumed. What is the pumping length that we have assumed? That is P. That is P. We have assumed P. Okay. Now let's check. Let's check. Will this string pump or not? A power P, B power P. Will this string pump or not? Will this string, will it help you? Will it help you or not? First of all, does it have authority to help you? This string, does it have authority to help you? Does it have authority to help you? This string, does it have authority to help you? This is not even a candidate string. This is not even a candidate string. This is not even a candidate string. Yes or no? This string is not even in the language. This string has no power. This string has no authority. Yes or no? This string cannot help you. This string has no authority. This string even does not belong to the language. This does not belong to the given language. Okay, so don't worry about this language. So I can say this language will, this string will definitely not help you. It is not going to help you. What about this string? You tell me, does it have authority? A power 2P, B power P. Yes, this has authority. Okay, so let's start with this. A power 2P, B power P. Okay, will it violate? See, this is your string. Your string is this. A power 2P and B power P. So there are 2PA and there is, and your pumping length that you have assumed. Your pumping length that you have assumed. We have assumed pumping length equal to P. We have assumed this. Okay, we have assumed the pumping length equal to P. So in which area you will find this Y? In which area you will find Y? In which area you will find Y? You will find Y in within the first P symbols. Yes or no? Within the first P symbols, you will find Y. Within the first P symbols. So this is your first P symbols. So remember, these are your first P symbols. Okay. And in these first P symbols, you will find Y. Find Y. So tell me, now you tell me, can you notice something interesting? Whatever Y you take, if you repeat it 0 times, can you notice this equation will disturb? Agree or not? See, in your language, if you notice, your language has something like this, that whatever number of B you have, number of A is double than that. Yes or no? Whatever number of B you have, this is the point. Whatever number of B you take, whatever number, for example, if I take B equal to 10, then A will be 20. For example, if I take B equal to 90, then A power will be 180. Okay, so you can easily notice. If I take B power 7, then A will be 14. So this type of strings you have. Okay, now you tell me one thing. Whatever Y I take, if I repeat it 0 times, will number of A be double than number of B? Right now, number of A is double than number of B. Right now, number of A is double than number of B. But this is the string we have taken. This is the string we have taken. This string. If I reduce at least one A, if I remove, will number of A be double than number of B? if I remove at least one A, if I remove, see, if I remove at least one A, then number of A will not be double than number of B. Yes or no? So very, very simple point. What I am saying that whatever Y you take, whatever Y you take, for all Y, what will happen? Repeat it 0 times. Okay, for all Y, you repeat it 0 times. In the resulting string, what will happen? In the resulting string, tell me, in the resulting string, can I say that definitely number of A is not double of number of B? Yes or no? Is not double of number of B. Is not double of number of B. Double of number of B. Agree with me? See, whatever Y you take, if you repeat it 0 times, if you repeat that Y 0 times, for example, let me give you one example. Like, for example, if I take Y equal to A, you tell me if I repeat 0 times, what string I will get? Just tell me. If I take Y equal to A and I repeat 0 times, what string I will get? Tell me what string I will get. I will get A power 2P minus 1, B power P. Does it belong to L? Does it belong to L? It does not belong to L. You tell me, if I take Y equal to double A, I repeat it 0 times. Now what will happen? Tell me. If I take Y equal to double A and I repeat it 0 times, I repeat this Y 0 times, I will get A power 2P minus 2, B power P. That also does not belong to L. So did you notice, whatever you do, I can say, this is the point. Whatever Y you take, if you repeat it 0 times, the resulting string, in the resulting string, number of A is not double than number of B. So finally, what I can say? So resulting string does not belong to L. Whatever Y you take, resulting string does not belong to L. Okay. For any Y, whatever Y you take, the resulting string does not belong to L. If you repeat 0 times, okay, whatever Y, repeat 0 times, okay, the string will not belong to L. So finally, pumping lemma fails. Yes or no? Yes or no? So this string is saying I will not pump. So I can say whatever P you take, for all P, so I can say for P, which string is saying I will not pump? This string, A power 2P, B power P. This string says I will not pump. Okay, this string will say I will not pump. If this string is not pumping, for any P, if this string is not pumping, what you can say about the original language? What you can say about the original language? This is your original language. And for this original language, you can see for all P, remember, for all P, there exists a W. Which is that W? Tell me, which is that W? That is like A power 2P, B power P. So for all P, there exists a W who does not pump. Okay. So I can say L fails pumping lemma. L fails pumping lemma. L fails pumping lemma. What you can say about now? If L is failing pumping lemma, what is L? L is definitely non-regular. L is non-regular. This is your answer. Okay. So you can see this string, is it helping you? This string, does it help you to prove non-regularity? This string, did it help you to prove not regular? Yes, this string has helped you. What about this string? First of all, is this a valid string? Is this a candidate string? Does it have authority? First of all, does it have authority? Of course. Does it have authority? No, this does not even have authority. First of all, this even does not belong to L. Right? See, this string does not even belong to L. This string does not even have authority. So forget about this. This string is not in L, if you notice. Is this point clear? Notice, for example, if P is 10, then what is this string? If P is 10, then what is this string? If P is 10, tell me. If P is 10, what is this string? This string like this, AAB, 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 Does it belong to L? Does it belong to L? It does not belong to L. Okay. Can you notice in this L, after B, A cannot come? In this L, in this language, after B, A cannot come. After B, A cannot come. So this does not belong to L. So this string will not help you. What about this string? Will it help you? What about this string? Will it help you? Will it help you? See, this string will also not help you because maybe P is 1000. See, this string will also not help you. Why? This string will not help you because we don't know what is P. P is random or not? Tell me. Are P is random or not? P is random. See, P is a random number. P can be 1000, P can be 1 trillion. This P can be, this is a random number. This is abstract number. This is a abstract number. This is abstract number. This can be very big. This can be, for example, this can be 1000. This can be 10,000. So this string is not going to help you. Did you notice? Only this string will help you because whatever P you take, see, if P is 10, then also option B will help. If P is 20, then also option B will help. If P is 10,000, then also option B will help. Agree with me? Yes or no? If P is 1 million, then also option B will help. If P is 1 trillion, then also option B will help. So option B will always help. Yes or no? Option B will always help. Did you understand this? See, this P is an abstract number. This P is not a specific number. This P is an abstract number. This can be any number. This can be 10,000. This can be 10. This can be 100. I hope this point is clear. Please tell me, did you understand? So for this question, the answer will be only, what will be the answer? The answer will be only option B. Okay. This string will always help you. कोई भी P ले आओ, कोई भी सिचुएशन, कैसी भी प्रॉब्लम P ले आओ, this string will help you. Yes or no? कोई भी नंबर P equal to any number you take, this string will help you. You can take P equal to any number. Whatever P you take, remember, whatever P you take, this string will help you. So the answer is option B. Now let's move on. I hope everything is clear so far. What about this question? Can I give this question as a homework? I think this is enough for today. Can I give this question as a homework? Let's discuss tomorrow. Okay. Let's discuss tomorrow. So take this question as a homework. This is a nice question. In this, multiple options will be correct. Let me tell you, this is MSQ questions and multiple strings will help you. There are multiple strings who will help you. But let me just ask you one thing. Which string you don't even have to check? Which string does not have authority to help you? Which string does not have power to help you? See, this is your language, equal number of 0 and equal number of ones. Okay, equal number of 0, equal number of ones. So which string? All the strings belong to L. Every string belongs to L. Every string belongs to L. Yeah. See, this string you can discard because this string will depend on will depend on P. Will depend on P. Notice this. Suppose length P is given. Do I know what is P? Suppose length P is given. Do I know what is P? No. P can be 10,000, 1 trillion, anything. Yes or no? P can be 99. So this string you can eliminate. The remaining you have to check. This is your homework question. I want correct answer from you. Okay. And please comment your answer. This video I will put on the YouTube channel. Please comment your answer. We will discuss it tomorrow. This question we will discuss in the beginning tomorrow. So comment your answer. Okay. See, you are not commenting. Many students, they are not commenting. Please comment. It will help us. That's the only point. Okay. If you comment, if you like the video, then it will help us. Okay. So now let's see. So this question also we will solve tomorrow. This question also we will study tomorrow. You can try, but don't worry about it. Okay. You can try this question. You can try. You just try. Okay. You just try, but don't worry about it. For example, I'm expecting answer for this and answer for this. This I will discuss. This I will discuss. So don't worry about it. So forget about it. Okay. You can leave it. This you can skip. You can think about it, but you can skip. Okay. Is this point clear? You can think about it. You can think about it maybe for 10 minutes. You can think about it. Give it 10 minutes. 10 minutes, 15 minutes. You think about it. but don't worry about it. Okay, I will discuss it. But you think, this is what I'm saying. You just think about it. सोचो इसके बारे में. Okay, so but these two I am expecting answer from you. For these two, for this and for this, for these two, comment your answer. Comment your answer. The question is asking minimum pumping length. The question is asking what is the minimum pumping length. So for these two questions, comment your answer. Okay, so see you tomorrow. Okay, so far everything is clear. Tell me, pumping lemma, did you understand? Did you understand pumping lemma? Can you say, is this your expression? So far, can you say that? Maza aaya. Okay, everyone. So let me know in the comments. Let me know. Do you agree with this? Maza aaya or not? Okay. So let's meet tomorrow. Tomorrow we will continue the discussion of pumping lemma. Tomorrow we will finish this pumping lemma. Okay. The pumping lemma will be over tomorrow. We will see the proof and we will see some more questions. But let me tell you, whatever we have seen so far, that is your pumping lemma. Now in future, whatever we will do, that is basically, I can say that you can also do. Whatever I am going to do in next class, that you can also do. Other than proof, the proof I will tell you. Okay. Why I want to tell you the proof? See, the proof, will it help you in the GATE exam? Will it help you in the GATE exam? Yes, it will help you. The pumping lemma proof is actually interesting. You can create new questions from it. Okay. So once we see the proof, after that, I will give you some MCQ, some multiple choice questions I will give you, which are based on the proof. If you don't know the proof, those questions you cannot solve. Okay. So there are some 3 or 4 questions which can be created based on the proof. Okay. So if you understand the proof is actually very easy. Let me tell you. So we will see the proof. After looking at the proof, those 3-4 questions we will solve. And after that, I can say that on internet, whatever question of pumping lemma is there, that you will be able to solve. Okay. So tomorrow we will continue. Thank you, everyone. See you tomorrow.